Today we're diving into Newton's third law of motion, okay? What are some things you guys already know about Newton's third law of motion? Knowing that for every action is a reaction, that's like the biggest thing, okay? That's like literally the entire point of Newton's third law. So make sure you guys are taking notes on this. Newton's third law of motion. Anytime a force is exerted on an object, that force is caused by another object, okay? So like you guys were saying, for every action, whatever action the first object caused, that same action most likely will become a reaction if it is applied into another object. Okay? So for example, if a hockey puck was sliding on ice to hit a wall, the wall will push it backwards. That's why the hockey pucks bounce off the wall. They're bouncing off because the wall is another object. The hockey puck is an object, and the action is the hockey puck hit the wall. The reaction is the wall hit the hockey puck back, hence why you get it bouncing back. So for example, we have this free diagram, this free body diagram, which is a drawing. No, understand that free body diagrams are related to drawing that show the actual force being applied on something. Okay? So when it comes to Newton's third law, here are some things to know, some key facts. 1, 2 objects have to be involved. 2 objects have to be involved. 2, know the action that one object is applying to another. It doesn't matter which object you focus on, but know what is the action one object is applying on another. So in this picture, what are the 2 objects that you definitely see? We see a table and we see a cat. Okay? What is the table doing to the cat?
Holding it.
It's holding it. Okay? That means for it to be held, what is happening to the cat is being held what? Held which direction? The cat is being held up. If it was being held down, the cat's head would not be relaxing right now. The table is holding the cat upwards. What's the cat doing to the table in return? What's the opposite of that?
It's pushing it down.
It's pushing it downwards. Okay? The table is holding or pulling it up while the cat is pulling the table down. So right there you have an action reaction. So like someone said in the past before in the last classes, so it's basically like a cycle. You're doing it to me, I'm doing it to you. You're doing it to me, I'm doing it to you. And we're doing it to each other because we are the 2 main objects in this moment. So like you guys were basically saying, for every action, there is a equal. The action must be equal. So that means the force itself is part of the action. Action is a force. So the force given has to be equal to the opposite force being received. And the opposite force will then give what it received. Does that make sense? I'm going to replace that again. I'm going to explain that again. You give something, you give the force. Like, for example, here's a better way to put that more in theory. I have a gift for Christmas. I give it to my cousin. My cousin receives the gift. Right there, the gift of giving is the action. The reaction that my cousin is going to go through is what? What is the What would the cousin do back to me? So I have a gift. The gift is technically a force. I give it to my cousin, which is me giving the force to my cousin. My cousin is going to receive and absorb that gift or that force. And now, in turn, what is my cousin going to be doing?
Giving you a gift.
Exactly. He's going to be taking that same amount of force. So if I spend $20, my cousin's probably going to say, hey, let me spend $20 too. If I spend $30, then my cousin's going to say, let me spend $30. What if I spent $100? What if my force is 100? What is the amount of force the cousin's going to give back to me then?
100.
100. So again, for the action I gave, which is 100 force to my cousin, the reaction is my cousin gave back 100 force equally. So it equals and balances out the actual forces being given. You give and then you receive. Because you received, you give. Make sense? In this slide, let's do a quick example. What do you see? What are the two objects in this picture? I'm going to zoom in. What are the two objects in this picture, especially the ones?
On the floor.
The person and the floor, the two objects. What is the action being done from this person to this floor?
He's doing push-ups.
He's doing push-ups. So he's pushing his weight. That's what he's doing. He's pushing his weight. Okay? And what was the floor doing to this person? What action is this floor giving to this person? What is the floor doing? Holding this person what? The floor is holding this person up. Just like the table. Just like the floor you walk on. The earth's crust is holding you up. That's why you don't go deeper into earth's crust. It's holding you up. Okay? If you look at this picture, what can you tell me are the two objects and what is the action? What are the two objects in this image?
The machine to launch the rocket.
The machine is one of the object. What's the other object that's being applied that force? Two things applying force. What are the two things?
Shuttle.
The shuttle is applying force. What else is applying force?
The rocket.
They're all one. So this entire thing right here is one. What is the other part that's applying force? We walk on it every day.
Floor.
The floor, the ground. So the ground is still an object. It's a physical object because you can physically walk on it. You can look at it. You can touch a ground. So when I ask you what the object is, I'm asking you for something a little more physical. Okay? The rocket is something physical that can apply force, and the ground is something physical that can apply force. These two things are creating an action. What is the rocket doing? What is the rocket actually doing? It's pushing up. It's pushing from the floor to go up. It's using the actual fire to push and apply a force downwards so that it can go up in the sky. What is
That's pretty. That's pretty cool.
Yeah. It's literally pushing down and going against Earth's gravitational pull. As it's pushing up, what is happening? What is the opposite? The rocket is pushing itself
up, yeah.
Yeah, it's pushing itself up. What's happening to the ground? What's the ground doing to the rocket though?
It's trying to pull it down.
It's trying to pull it down. It's doing the opposite. You trying to go up, I'm trying to bring you right back down. So one of the forces have to be great enough to actually make it. So that means the rocket is using the hot gases, the actual fire, as an extra boost to go against the Earth's gravitational pull. That's how it gets into space. It's like the fire from a gun is what is pushing the bullet out. The fire from this rocket is what's pushing it up. Okay. Any questions? So then we're going to do a quick exemplar. I'm going to go to this example for a moment. The two examples here. So as you're sitting on a chair, you feel the chair pushing on you. What would be the opposite reaction? Now remember, you have to think two questions. What is the subjects? And the second question, what are the subjects doing? What action are they causing? So what are the two subjects in question 34? So that's pretty much it for today. Okay, you guys, do you have any questions for me?
No.
Okay.